Hi everyone, today let's solve the problem number 304, range sum query 2D immutable, right? So what the question states here, so we are given a 2D matrix and we need to support multiple queries where each query returns the sum of rectangular submatrix from row 1, column 1 to row 2 to column 2. So let me come to the example part. Let me show you the things so we understand the things clearly, right? So we have been given a 2D matrix. So you can clearly see here, we have been given a 2D matrix, right? So this one I'm speaking of the input. So we are given a 2D matrix. So in the example one, they have clearly mentioned here, right? Matrix. So we are given a 2D matrix and need to support the multiple queries where each query returns the sum of rectangular submatrix from row 1, column 1 to row 2 to the column 2. So what we need to implement here, we need to implement the num matrix class with two methods. So this one is constructor method, this one initialization part, nothing but the initialization part. Constructor to initialize the matrix, this one, this part I'm speaking of. Another one is sum region, nothing but we need to return the sum of submatrix and big O of one time. They have clearly mentioned we need to return the sum of a submatrix and big O of one time. So we need to use the pre-processing with a prefix sums plus hashing. So that's what they have mentioned. So this is the best thing to use basically. When I say sum region to return the sum of submatrix in big of one time. So they have asked us to find the sum region to return the sum of submatrix in big of one time, right? So the best thing that we can do here is we can go with a pre-processing with prefix sums and hashing. So this approach is the best, right? What we are doing, again I'm telling, we will be going with the pre-processing with the prefix sums plus hashing. So output, so let's come to the input output part here. So here let's discuss the approach in depth later. First thing, let's try to understand certain things here. So here you can clearly see num matrix sum region, three sum region we have, and the num matrix. Num matrix here, this one is the initialization part and the return value is always null. So here we got null, and we have to get the this one based on the matrix they have given. We have to get the output 8, 11 and 12. Let's see that one in the approach. So I hope the question part is completely clear. Basically what we need to do is completely clear. So what shall we do first? Let's discuss the approach followed by the complexities for the code that we'll be writing in the future. So first, let's discuss the approach. So here, I have considered the same first example that they have given in the question so that it will be easier to understand, right? So here, mm as I've said, we will be going with the hash map approach, right? So we will be going with the hashing. So I'll just call this one hashing for now. Prefix sum plus hashing. So let me write this in this way. Prefix sum plus hashing or hashing plus prefix sum, right? So I hope this part is completely clear. Let's do one thing. Let's discuss this one step by step. Just give me a second here. So did I forget something? No, right? So yeah, here, let's do one thing. Let's go with the 2D prefix sum idea. So we have already discussed that this one that we'll be going with a 2D prefix sum along with a hashing, right? So here in this case, if you observe, if you would have observed, so we got the output null 8 13 something. I don't remember exactly, just give me a second here. Yeah, we got the output null 8 11 and 12, sorry, not 13, 11 and 12, right? Based on the matrix that they have given. So we will discuss, let's discuss how we got 8, and you can just try it out for the 11 and 12 in the same way. So null, we know that the return value of the this one constructor initial value num matrix is nothing but null. The return value is always null for the initialization part. So here we got null in this way. So I will show how we got 8. Basically you can just try it out for the 11 and 12 in the same way. This is nothing but the query 1, right? I'm speaking of this one 8, right? So let's go with the 2D prefix sum idea. Here we will be making use of the prefix sum pre of ij to represent the sum from 0, 0 to I minus 1 comma j minus 1, nothing but from this one 0 comma 0 to this one I minus 1 j minus 1 as last this one last cell, right? So here to find the sum of any rectangle from this one row 1 column 1, this is nothing but row 1 column 1, I have given r1 c1 to row 2 column 2, nothing but r2 to c2. So sum is nothing but, so this is the formula that we need to keep in mind to this is nothing but we are going with the prefix sum idea, right? 2D prefix sum idea. Here this is nothing but prefix of r2 plus 1, nothing but row 2 plus 1 and column 2 plus 1 minus prefix of row 1 and C2 plus 1 and prefix of row 2 plus 1 C1 plus this one is minus, nothing but minus, and this one is for the last one, this is plus prefix of R1 C1, nothing but the row 1 C1. So for the query we are going with the sum region 2143, right? So this is for the first one. How we got basically we are doing it for the 8, right? Null 8, 11 and 12 we got. So if I show this one, you will come to know this part I'm speaking of. So just give me a second. Where is this? Yeah, this part. So some region for the 8 is this one, for this one is 2143. For the 11 the sum region is 1122, and for the this thing 12 the sum region is 1224. We are going with, currently we are going with this one 2143. So what we will do, we will convert to one based indexing. From zero based indexing we will convert to one based indexing for the pre-matrix. So r1 we are having 2, this one 2143 part I'm considering. Don't get confused right here. So r1 is 2, c1 is 1, right? R1 becomes 2 plus 1, nothing but 3. C1 becomes 1 plus 1, nothing but 2 here in this case. We are just converting this one to the 1 based indexing. Here, this one from 2 it becomes 3, from 1 it becomes 2. The same thing goes with R2, C2. Means 4 becomes 5 and 3 becomes 4. Right, so you can clearly see here we have successfully converted to one based indexing. Next, after converting to the one based index, we will apply the inclusion exclusion formula. Right, this is nothing but we know this one prefix of 54, prefix of 34, prefix of 52 and prefix of 32, nothing but from the pre-computed prefix sum hash map. So we will calculate in this way. So we will go with prefix of 54 is nothing but from some 0 comma 0 to 4 comma 3 we get 38, right? From 0 comma 0 to 2 comma 3 we get 21, and from 0 comma 0 to 4 comma 1 we get 16, and from 0 comma 0 to 2 comma 1 we get 11. This one I'm speaking of, right? So we got 38, 21, 16 and 11. This is nothing but the pre-computed prefix sum. This is nothing but pre-computed prefix sum. We have already discussed this one from the previous step. This one I'm speaking of, right? Not this one basically. Yeah, this one I'm speaking of. Now we apply the same thing here. So this one prefix of r2 plus 1 c2 plus 1 minus prefix of r1 c2 plus 1 minus prefix of r2 plus 1 c1 plus prefix of r1 c1. This one, let's apply the same thing here. Let me come here. We got 38, 21, 16 and 11. So now sum is 38 minus 21 minus 16 accordingly with the formula. So this one 11 plus 11 for the last one. So 38 minus 21 is nothing but this one. What do we call? 17. 17 minus 16 is 1. This one. Just give me a second here. So sorry. Here I have considered the wrong calculation, I think. So we have to go with here. So this is prefix of 5, 4, 3, 4, 5, 2 and 3, 2, right? So this is not 38, 21, 16 and 11. Basically this is the calculation part is wrong. So this has to be 54 minus 24 minus 27 plus 5. So this has to be 54 minus 24 is nothing but 30. 30 minus 27 is nothing but 3. 3 plus 5 is nothing but 8. So the total output is here. So this one have considered wrong basically. So that is the reason we are getting the wrong answer. So this is fine. Now we have got the output 8. So the final output sequences, so the sum for the sum region we have calculated this one. You can just try it out in the same way for 1122 and 1224. So for this one we have got the output 8, and for other two you will get the output 11 and 12. You can just try it out in the same way that I showed for 8, right? So this, that is nothing but 2D prefix sum hash map, right? So 2D prefix sum using hash map. So you can just try it out in the same way that I showed for the first one, right? So here we got the output 8. You can just try it out for this one, 11 as well as 12. So I hope the answer is completely clear. Now let's quickly discuss, I mean, I hope the approach is completely clear, right? So now let's quickly discuss the complexities. So here the time complexity for the code that we'll be writing is big O of m into n for the constructor, and for the sum region it will be big O of 1. Just give me a second here. Yeah, for the sum region it will be big O of 1, right? So why it is big O of 1 for the sum region? Because we are uh, going with a constant hash lookups for this one I'm speaking of, right? So this is construct of nothing but the initialization part. Some region it is big of 1 because due to the constant hash lookups, right? So we'll be, as I've said, we'll be going with the hashing. So you'll come to know when we write the code. So we haven't written the code, we are just discussing accordingly with the approach, right, that we discussed earlier. So the space complexity would be big of m into n, because in the worst case we have to store all the prefix sums in the hash map, right? So that is the reason space complexity is big of m into n here for this one. So the time complexity would be big of m into n for the constructor, and for the sum region method it would be big of 1, and the space complexity would be big of m into n. I hope this is completely clear, right? The complexities part. Now, as we are completely familiar with the approach along with the complexities, let's start writing the code. So let's start writing the code. Basically, this is not the ideal question to be asked in the interview. To be frank, it's completely based on the formulae, right? So let's do one thing. Let's finish this one very quickly. So within this one, what do you call? Within the class num matrix. So this one, let me do one thing. Let's go with the 2D prefix sum array to store the cumulative sums. We have to store the cumulative sum somewhere, right? So let's make use of the 2D prefix sum array as we discussed in the approach. So I'll just go with private int. So this one, let me give pre. So this is fine. So within the num matrix, nothing but the initialization part, right? So let's initialize the rows and columns here first. So I'll just go with m equals um, matrix dot length, and int n equals this one. I'll just go with matrix of 0 dot length. So this is fine. The next one is we have to initialize the prefix array with the one extra row and column for the easy boundary handling. So let's do that one. I'll just go with pre equals new. So this will be int. So I has to be small, right? So new int of one, this one we are converting from 0 based indexing to 1 based indexing right here. So that's what accordingly with the approach, if you remember. So this will be m plus 1 and this will be n plus 1. We are just initializing the prefix array with one extra row and column just for the easier boundary handling. After doing this one, let's build the prefix sum matrix. Means we know the formula, man. Let's just build it. So I'll just write it in the form of code rather than explaining more. So this is for the rows. Int I equals 0, I less than m, I plus plus. This is fine. And for this one, this is int j equals 0, j less than n, j plus plus. This is fine. So within this for loop, what we'll do, we'll go with the formula. So this is the formula. Prefix of this one will be I plus 1, j plus 1, equals matrix of, oh, let me go with the I, j, and this one is pre of I, this one is j plus 1, and this one is pre of I plus 1. This is nothing but j, and this is nothing but I'll just give minus here, minus pre of I, j. So I hope this part is completely clear. Let me come out of this one. So this is for the num matrix initialization part. So let's come with the um, other method, nothing but the sum region here. We have row 1, column 1, row 2, and column 2. These two are completely based on the formula. Again, we'll just be going with the formula. We just have to return um, how we calculated this one, how we got 8. I showed you with one formula, right? So the same formula we just need to return. That is the reason I said that this is not the ideal thing to ask in the interview. You can just ignore if you don't want to know, but if you can just solve, if you are curious or if you are interested in solving this problem, you can just solve. So let me go with this part. Return pre of row 2 plus 1, and this one will be column 2 plus 1. This is fine. Minus pre of, if you remember, row 1, uh, this will be column 2 plus 1, and the next one is minus pre is nothing but the prefix sum, right? So this one will be pre of row 2 plus 1, and this one will be column 1. This one will be plus pre of row 1 and column 1. So that's what this is, completely formula. This one, pre of row 2 plus 1, this one, this part is nothing but total rectangle from 0 comma 0 to row 2 comma column 2. This one we have discussed in the approach itself. And this one, pre of minus pre of row 1 and column 2 plus 1, whatever I have written here, this one we have made use of this one to remove the top strip, right? And this one to remove the left strip. So first one, this one to remove the top strip, and this one to remove the left strip. And the final one, pre of row 1 column 1, whatever I have given here, this one is to add back the overlap top left block. This one, the last one I'm speaking of, right? So the line number 19, this one 19 I'm speaking of, last one, pre row 1 column 1. This one is nothing. We are just adding back or we just have to add back overlap top left block here. For that reason, we are making use of this one. This is just the formula. You have to mug up this one, basically. So that is the reason, again I said, this is not the ideal problem to ask in the interview, basically. So this is fine. Let me hit the run button, and let me hit the run button. I hope this works. Let's see. We have the compile error. I forgot int, I think. Line number 12. Yeah, I have to mention int here. So this is fine. Let me hit the run button again. So here you can clearly see here the sample test case is getting passed. So let me hit the submit button quickly. So you can clearly see here all the test cases are getting passed, means the code works absolutely correct in this case, right? So what we did, initially we discussed the problem, then accordingly with the problem we discussed the approach as well as the complexities for the code that we'll be writing with, and we wrote the code, and now the code got accepted, means all the test cases are getting passed, means the code works absolutely correct, right? I hope the solution part is completely clear. For now, this is it. Thanks for watching, guys.